So this is our lecture number 5, and all the doubts you may have of chapter number 3 will be cleared in this lecture because we will be solving numericals of chapter number 3, and by this we will clear all the doubts you may have. So here in this question we need to find specific volume, internal energy and enthalpy of compressed liquid. So compressed liquid region is given to us at 100 degrees Celsius and 15 megapascal using the saturated liquid approximation. So what is the saturated liquid approximation? Previously in previous lecture we studied this. In saturated liquid approximation, for example, here compressed liquid is given to us, and for compressed liquid we will be using table A7 actually, but according to saturated liquid approximation we can use our table A4. So further he says that compare these values to the one obtained from the compressed liquid table. So we actually need to compare the values of we will get from table A4 with the values we will get from table A7, and after that we will actually differentiate each other and find out the actual results. So let's start. Here we have 100 degrees Celsius given to us, and why are we actually seeing the value of Vf, why not Vg? Actually Vf is for compressed liquid, the process is from 1 to 2. If you remember that diagram was something like this. So this region we are in compressed liquid. This is the compressed liquid, this is saturated mixture, and this is superheated, and Vf is actually here. Vf is here, and Vg is here, and Vfg is in between. Vfg is in between. So actually Vf is the value we will be taking because here we in compressed liquid no vapor is formed yet, so we will be using Vf, and when he will talk about that our state is superheated, then we will go for Vg. So we have taken the values of Vf here we have taken the value of Vf, and after that we will take the value of Uf, which is internal energy, and after that we will see the enthalpy, which is Hf. So these three values we have taken these three values at 100 degrees Celsius. In the next slide let's see. So we have already found the values of table A4, which were approximate values. Now we will be finding exact value to table A7 because it was written the compressed liquid water. So compressed liquid table is actually A7, and here we will look into pressure is equal to 15 megapascal and temperature is equal to 100 degrees Celsius. So here we have 5 megapascal, here we have 10 megapascal, and here we have 15 megapascal. So this is the right table, and in temperature we will be looking at 100 degrees Celsius, and we'll slide into here and find out the value of V, U and H. So we have wrote this value here, but I have a question for you, that why table A7 does not contain the value of Vf, Uf, Hg, or like in table A4 we have Vf, Vg values as well, not the single values. So the answer of that is that table A4 is saturated mixture table. They contain both the value of Vf and Vg, because Vf is a saturated liquid and Vg is saturated vapor. Now, but compressed liquid is actually where no vaporization has occurred yet, so the values are actually certain. So we do not have Vf or Vg, we only have a single value. So these were the values we obtained in table A4, which were approximate values. So how we will find the percentage error of each value? So percentage error for V, we are finding for V now, volume. So here we need to write the value of exact value of volume, which will be of table A7, which is 0.001036 minus approximate value, which is here 0.01043, and divided by V exact, the same value we wrote it here, and we will multiply by 100, so we'll get the percentage error. So percentage error for V is 0.67, and the same we will be following for U and H as well, and we find the answer, which is 1.01 and 2.60. So these are very small error, so it actually satisfies our conditions that we said that we can use our table A4 instead of table A7, because the percentage error is actually very small. So whenever you are solving this numerical, I must recommend that you should actually make this graph, so this will make things easy for you. From this region to from this point to this point, we have compressed liquid now, and currently right now at this point, this is called VF, and this is also known as saturated liquid. And from this line, this whole line is saturated mixture, which is in between VF and VG, and VG is saturated vapor, and anything above this will be, this line, whole line is superheated region. So let's just assume that we are at VF, or we are at saturated liquid, and anything below this will be compressed region, and anything above this will be saturated mixture, and same goes for VG. Anything above this will be superheated region, and anything below this will be our saturated mixture. So let's just assume that these three conditions are our questions, and currently and our current situation is, or our current condition is this V. So he is saying if our current condition is less than VF, then in which region we will be. So obviously if we are less than VF, so we will be below VF, this region will be compressed liquid. So he answered that if answer is the first question is yes, the state is in the compressed liquid region. So we were right. And second question is, if we are in if we our condition is greater than VF but less than VG. So if we are greater than VF, so greater than VF means we are at saturated mixture, and less than VG means that we are at saturated mixture. We are in this line, this whole line, we are somewhere here, or not somewhere here, neither we are somewhere here, we are in this between, we are in between. So what that will be? So that is saturated mixture, we know that. So let's say what does the answer says. So we're in saturation region, which is also called saturated mixture. So we were right. So for this, if Vg, so if our current condition is actually greater than Vg, so if we are greater than Vg, then we will be at superheated region, right? So if third question is yes, then we are at superheated region, so we were right. So I also want you to know that what is a greater than sign. If this is a backward sign, this means so anything that on the left will be the lesser, and anything on the right will be greater. For example, if you just consider this side, then Vf is less and V is greater. But if you just only consider this factor, if you remove this factor, we have just this factor, this whole factor. If we only have this factor, then what will be our answer? Then this means that V is small and Vg is greater. It's the same goes for this. This our Vg is less and V is greater. I hope you understand the question now. So if this condition is right, then V actually lies in compressed region. And why is that? If you actually see that that we are less than Vf and less than Vs is compressed region. For compressed region, we use the compressed table, which is table A7, or we can also use our table A4 as well. But if we are in this, which we already discussed it, this was our saturated mixture. And saturated mixture, we use the table A4 and table A5 as well, depending on whether we have temperature or pressure is given to us. And this was our superheated region, and superheated we use table A6. So in the previous lecture I asked you to memorize this table, but at that time you won't be able to understand this table. But right now you can easily understand this this table, or either without memorizing this table, you can just make this graph and write the Vf, Vg here, and you will easily you can easily identify your region, at what region you're currently at. This is compressed liquid, this is compressed region, this is saturated region, and this is superheated, while Vf is our what we call that saturated liquid, and this is our saturated vapor. So all the conditions are given to you, that when we will have compressed liquid, when we will have saturated liquid, and when we have saturated liquid vapor, and so on. So you can actually either make this graph or memorize this table. Now both are convenient, but mostly recommended is that you actually make this graph. So we know that our compressed region is here and superheated region is here, and actually our values start from Vf, which is 0, and Vg, which is 1, and after that at superheated V does not have any value, we do not have any value. And also the same case for compressed region, we do not have any value. And what we write instead on this, on the block, for compressed region we will be using nil, and also for superheated region we will be using nil. And in between 0 and 0 in 1 we have a saturated mixture, and we will and it will only be from 0 to 1. And at 0 we will say this is our saturated liquid, and at 1 we will say this is our saturated vapor. So here in this question, pressure is given to us, quality is given to us, and we need to describe our phase or describe our region. We also need to find enthalpy and temperature. So pressure is given to us, we will be using our table A5. Table is A5 is of pressure. Actually you can pause the video and move towards the next slide and check the table A5. While I just have a snapshot, but you can't see the which is the temperature values, which are enthalpy value, which are volume value. So I recommend you to pause the video and check the next slide. So now we need to find the temperature first. For pressure 200 kilopascal, the temperature is 120.21 degrees Celsius. So this is our temperature. We will write it here. And also we need to describe the phase. So what will be our phase description? So we know that from 0 to 1, in between anything, we will have our saturated mixture. So this is actually, we are at saturated mixture, and we can say 0.7 as 70%, and 70% is saturated vapor, and while the remaining 30% is saturated liquid. So 0.7 is the vapor quantity, while the remaining 30% is of liquid. And in order to find our H, we know that we are in saturated mixture, and we need to find the HFG. And how we'll find the HFG? So here we have the formula for finding HFG, that we will rearrange our equation for HFG. We know the quality, we know the HF, this is our HF, and we also know our this H. So we will find our HFG. So we have 504.71, which is our HF, plus we also know our 0.7. And for HFG, we will use our HF minus HG minus HF. So here we have this HFG 2706.3 and minus HF, which is 504.71. So that's how we will get our H value, which is 2045.8 kilojoule per kg. So we have completed our row 1, and after that we need to complete our remaining rows. So in row 2, the temperature is given to us. We need to find the value of quality and phase description as well as pressure, while enthalpy is given to us. So as temperature is given to us, we will be looking into table A4, which is temperature table. So at 140 degrees Celsius, actually you can go forward and see the table A4. While here I just have the small screenshot. While at 140 degrees Celsius, the pressure is 361.53. So we can write the 361.53 here. And after that, enthalpy is given to us. But in order to find the phase, our phase, we actually can compare our value. So our value must be in between 1800, near to 1800, and how we will know that? So this is our HF, and this is our HG, and this is our HFG. So our value should be in between them, in between these three values. So 589 is our starting, and our end is 2733. So our value is in between, so we can say this is our uh, HFG. So we can say that we are in saturated mixture. So in order to find the X value, in order to find the value of X, we will use the same formula, which is H is equal to HF plus X HFG. We will rearrange our equation and put the remaining values. For H we will use the 1800, for HF we will use 589.16, plus we need to find this vector, and for HFG we will subtract these two values, and we will find our X value. So I'll make the diagram as well, that's what I'm talking about. This is our HF, this is our HG. So he have given us the value of H, which is 1800, while his HF is 500 something, 500 something. while his end value, which is at G, is 2733. 2733. So while our value is 1800, so it is in between somewhere here. In between somewhere here, it can be here, it can be here. So what is this line? This line is called saturated mixture. So saturated mixture, here it is written. That is how we know that this is our saturated liquid vapor mixture. So we can write this here, over here. We just need to find the value of x. We just did that over here. So we also completed our row 2, and next we will move into row 3. So there's one thing that I forgot to mention, that for example here 0.7 was given to us, so we knew that saturated, this is our saturated mixture, and anything in saturated mixture is given to us, then we take our properties as Fg. For example, if we need to find the volume, then we will use Vfg. If we need to find enthalpy, then we will be using Hfg. But for here 0 is given to us, it means this is our saturated liquid, and all the values we will be looking for will be Vf, Hf or Uf. We won't be using any other values, and they are not relevant to us. But if Ug was given to us, or 1 was written here, it will be saturated vapor, and all the values we will be seeing will be Ug, Hg and Vf. Yeah, I hope you will understand, but we will also be solving numericals, so we will understand what I am talking about. So here 0 was written, we will straightforward write the saturated liquid here. We just need to find the H and temperature. So for temperature, we will look into table A5, because A5 is the pressure table, and in at 950 degree at 950 kilopascal, the temperature is 177.66 degrees Celsius. While we will look into HF, here we will write the HF. The HF value was 752.74. While all the remaining factors will be written, we found the phase description, we found the HF value, we also found the temperature value. So we'll move into our next row, which is when temperature and pressure is given to you, like here in this case 80 degrees Celsius given to us and 500 kilopascal is given to us, then in such cases we will prefer a pressure table. And if you won't find the values here, then we will go back to our temperature table, which is A4. But we are now preferring our table A5, which is pressure table. So at 500 kilopascal our temperature is 151.83. And if we compare our temperature, our given temperature is 80 degrees Celsius. So our given is T, which is 80 degrees Celsius, it is below, and our saturated is Tsat, Tsat, T saturated. So we are actually in compressed region. If you memorize the table that I told you that to memorize it, if you look into that table, you will find out we are in a compressed region. So in compressed region we will be looking into all the values in F, HF, UF, VF. So we will look into table A4, and when you're going back, here we have our 80 degrees Celsius, and after looking at the value, 335.0 is mentioned. So we will write it here, and our phase description will be compressed. We will write here as nil, x value nil, and phase description will be compressed region. And here's one more thing, that we, after when we will look into table A5 and want to find our value, so we will move back to table A4, and we won't see the pressure there. We will only see the uh, temperature, because our pressure here is less. You can see actually our pressure was 500 degrees Celsius. There must be 5 degrees Celsius, but that's not the case, because we are in a compressed region. That's how we know that we are actually in compressed region. We will only look into temperature value and whatever we need to find. So here we have 800 kilopascal, and H is given to us, which is 3400. So so uh, first we will look into table A5 because pressure is mentioned. For at table A5, 800 kilopascal, we will actually see our whether we are at in right table or not. We will check this by the value of H. So our H should rely in between these values. So here we have 3400, while our first value starts from 720 and ends on 2768, while our value is 3400. So this is a greater value than that. Then we will move into superheated region. If the value was less than that, if the value was at 700 uh, and our starting was 720, then we could have said that we are in compressed region. But our value is actually greater than Hg, then we are moving into our superheated region. And at table A6, because we are finding temperature, we will look into table A6. So here at A6 we will see at 0.8 megapascal, because 0.8 megapascal is equivalent to 800 kilopascal if you convert that. So firstly we found the table, and the other thing we will be looking into 3400. So 3400 is in between 3267 and 3481, so it's in between them. So how we will find that? So for that we have a method we will look into on our next slide. So what's that method? So this is our method. Firstly we need to, whatever we need to find, so we need to find our temperature, and temperature is in between these two values, 400 and 500. So here we will write the 400, and here we will write the 500, and here we will write the value we need to find, whether it is temperature or H or U, V, whatever we need to find, we will write that here. For example, if we need to find the value something in between them, then we would have used the V. But here we need to find the temperature, and here we have three values. The one that we need to find, the one that is above that, which is 3267, and the one that is below that, which is 3481.3. So we have these three values, and now we can easily find our temperature value. So the value we need to find, we will write it at first, minus initial value divided by final value minus initial value. So this is the formula, you need to memorize this. The required minus initial divided by final minus initial. Same goes for this. 3400, that is our middle value, minus initial value divided by final minus initial, and after solving this we will find our temperature. So our temperature is 461.93, and we are in superheated region. We will use nil for that, and our region will be superheated, so quality will be nil. These are our final answers. I recommend you to solve this numerical because you should know the. So here we have a piston cylinder device. So any piston cylinder device at least have two states or more than two states. So initially, so the first state is 50 liter of liquid water is given to us. So this means that we are in a compressed region because we have initially 15 liter of liquid water, nothing is yet in vaporized form, and temperature is given to us, T1 is given to us, which is 40 degrees Celsius, and P1 pressure 1 is given to us, which is 200 kilopascal. And after that heat is transferred to the water. So heat is given to the water at constant pressure, so P2 is also 200 kilopascal uh, until the entire liquid is vaporized. So the another state is given to us, which is saturated vapor. So all the liquid is converted into vapor, so saturated vapor is also given to us. So here we have two states. So what is the mass of water? We need to calculate the mass. We also need to find the final temperature, which is T1 is given to us. We need to find our temperature to determine total enthalpy change. We need to find the delta H and show the process on a TV diagram with respect to saturation lines. So let's start. Uh, so our 50 liter V1 is equal to 50 liter, and if we convert it into m cube, it will be 0.05 m cube, while T1 is 40 degrees Celsius and P1 P2 is equal to 200 kilopascal. So in order to find our mass, we have this formula, which is mass is equal to volume 1 divided by specific volume. So by looking into table A4, as temperature is given to us, uh, by looking into table A4, we will find our volume value, and we also know our V value, which is 0.05 m cube. So if we divide these both value, we will get 49.61 kg m1. So this is how we get our mass. So in order to find our temperature 2, we know that our pressure 2 is 200 kilopascal. By looking into table A5, we can find our temperature 2, which is 121.21 degrees Celsius. So here's one thing, that our state 1 is in compressed liquid, while our state 2 is in saturated vapor. So by the graph from here and here, this is our G, this is our G, this is our F. So we have our compressed region. All the values you will be seeing here in state 1 as VF or HF, while in state 2 all the values we will see in table will be VG or HG. So here in state 1, in order to find our delta H, we have studied this formula in chapter number 2, which is mass multiplied by enthalpy minus enthalpy minus H2 minus H1. So this is final enthalpy, this is initial enthalpy. In order to find the initial enthalpy, we have this formula, H1 is equal to HF at 20 and 40 degrees Celsius. By looking into table A4, we can find our enthalpy. The same goes for the H2, as this will be in saturated vapor. So at 200 degrees Celsius and 200 kilopascal, by looking into table A5 we can find this value, and after solving this we will also get our delta H, and this is the TV diagram for our process.